Okay, rational exponents. And again, if I see something I like better than first period, I'll write it in by hand or type it in. Rational exponents. Rational means a number that can be expressed as a fraction. Anything can be expressed as a fraction. Okay, is automatically a rational number. A couple of confusing things to that, which sound like exceptions. One of them is complex numbers. Even if they're in a fraction, they don't count for what we're talking about today. So we're just talking about rational numbers. Ask first period to call out some examples of rational numbers. Anything which can be expressed as a fraction. Notice this can be part. It doesn't have to be expressed as a fraction. So for example, 1 is rational because you can write it as 1 over 1.
And then any number, because you can do 2 equals, oh wait, no.
Any integer.
Because you can have 1 equals 2 equals 1.
Yeah.
Or I mean 2 equals 2.
2 equals 2 over 1, yeah. Yes, any integer can be made into a fraction. So any integer, 1, 57, 2, which we have here is 12 over 6. Those are all rational numbers. Most decimals can also be written that way. Because your decimal, 0.5, for example, can be written as 1/2. Any questions about the examples you can see? Up there. 1, 57, 12 over 6, 0.5. Why they're rational numbers. You know what I didn't do is put any negative examples in, so I'll do that here. This next one, 0.098745376, is a rational number. Because you can always rewrite any decimal that ends as every number you see, take away the 0, 9874536, over a 1 followed by how many zeros? Well, how many spaces do I have after the decimal? 1, 2, 3, 4, 5, 6, 7, 8, 9. So I take 9874536 and put it over a 1 followed by 9 zeros. So any decimal, no matter how ugly, as long as it ends, will be a rational number. Who knows what the one example is of, let me add to this here for a second. Who knows what your one example is of a decimal that goes on forever but is still rational?
Pi.
Pi is irrational because it goes on forever without repeating in a pattern. Okay, that's a good point. You're right. Pi does go on forever, but there's no pattern to it. What's an example of one that goes on forever but there is a pattern?
Third, 1/3.
Pardon? 1/3. Perfect. That's it. 1/3 equals 0.333333. I'm going to put a dot, dot, dot to indicate it keeps going like that. Or, you guys remember this symbol? Give me a moment to find it. It's quite hard. Come on in. Okay, so 1/3 is a great example. So that's another example of this is still a rational number, because even though it goes on forever, it can be rewritten as 1/3. It can be rewritten as 1/3. We will. What are some irrational numbers?
I, E.
The actual definition, I is not actually. And again, I'm going to write it in a second. Irrational number is can't be expressed as a fraction. That's actually like a
Nice spelling.
Yeah, wow.
I know, doing great here. There we go. Can't be expressed. Irrational numbers cannot be expressed as a fraction. That's our actual definition. What that means is decimals which go on forever without any repeating pattern. Decimals which go on forever without any repeating pattern. What's the first example of that you probably learned?
Pi.
Pi. Okay? Pi is the most common example of it. What's the one we talked about earlier this year?
Don't have some like weird name.
Well, E we also talked about as being one, yeah. E is one. We'll get more into what why E is irrational later. What did I tell you about any square root if there's not a perfect square under there?
It's irrational.
It's irrational. It goes on forever with no repeating pattern to the decimal. Okay? Keeps going on forever and ever. So you take the square root of 2, it's going to go on forever. It starts at about 1.4. It goes on forever there. You get the square root of 3, that's also irrational. You get to the square root of 4, that's rational, because what is the square root of 4? 2. So that's 2 over 1. Life is good. Alright. Complex imaginary numbers are not rational, even though they can be part of a fraction. Just put that in there to say we're not going to talk about I during this part of it. Okay? You can have I in a fraction. For that matter, you can have pi and e in a fraction. But when you do, it's still not a rational expression. Okay.
What about a number with an exponent?
I'm sorry?
A number with an exponent.
Depends on the exponent. Great question.
If it's negative?
If it's negative, it's a fraction. That's automatic. Like if you just say 2, let's do one of those up
Yeah,
here.
did you flip it? Okay.
Yeah, because you flip it, it's still expressed as a fraction. So if I do something like 2 to the negative 3, that's just 1 over 2 cubed, which is 1/8. It's still rational. Now, if I can do things to this exponent, I can actually put like pi or I or square root up here, and then I'll create something irrational. But we're not going to get to examples of that yet. All right, but right now what we're going to do is we're going to put rational numbers into exponents. Okay, rational exponents, sentence down here at the bottom. Use fractions to express radical roots. The denominator is the root you're looking for. Oh, I didn't do any examples of complex. So this is just, what this sentence is basically saying for purpose of this lesson is, we're not using I. Don't worry about that. I won't give you any negative square roots this lesson. Use negative cube roots. We'll talk about that in a second. This is just, first we're just going to talk notation. Okay, there's no difference now from stuff you've already done, except we're going to write the square root of 2 as 2 to the 1/2 power. The denominator of the fraction that's in the exponent spot is the root you're looking for. Okay? How quickly this goes is going to depend on how comfortable you are with cubes and fourth roots and things like that. Some of you have seen them before, some of you haven't. So we have to add some of that. But the first thing you got to know is, instead of a radical sign, you raise the base to an exponent, and the denominator is the root you're looking for. Now, here's another example. Cube roots. Who remembers what a cube root means?
Oh, it's like square root, but cubed.
Yeah.
It's like square root but cubed.
Yeah.
Okay, you're right.